Since the early days of science, researchers have been looking for patterns among the elements. By the 1860s, a huge amount of observational data was available. In 1872, Dmitri Mendeleev published the periodic table, which made him famous. Not only was Mendeleev's organization of the elements a milestone, but it enabled him to predict the properties of elements that hadn't even been discovered yet.
In Mendeleev's table, the elements were listed in order of increasing atomic mass. But he started a new row when similar chemical behaviors were repeated periodically. That's why it's called the periodic table.
So we should be able to compare our groups to Mendeleev's.
Good idea.
Our table shows calcium and magnesium as a group.
Here they are. Mendeleev puts them in a group too.
And we have potassium and sodium as a group.
Okay, they're in a group as well.
What about the nonmetals?
Well, we have iodine and chlorine together.
Here?
And we have neon and argon.
I can't find them. They aren't here.
Really? Why not?
Remember, we're using a periodic table that was made in 1872. Neon and argon weren't discovered until 20 years later.
So what exactly do astronomers look for, or scientists look for, when they're considering the possibility of life on other planets? Well, first of all, temperature. It can't be too hot and it can't be too cold. It has to be just right, the temperature necessary for liquid water. At least life here on Earth appears to be dependent on the presence of liquid water. After that, an atmosphere would be nice. It appears that most life likes to have an atmosphere. And of course, there has to be a certain amount of chemicals in the oceans or in the water. The stars that the planet is orbiting around has to be stable. It can't live too shortly, have a short period of time for its life, and it can't be unstable during its lifetime. So it has to be a very stable star like our sun. And so these are some of the things that astronomers look for when they're considering the possibility of life on other planets.